Hello, my dear G students. After long period, I am back to our channel. That means that we are back to the channel G Jama Institute of Excellence. So, welcome back. And today we are going to learn that class 12th of that organic chemistry. So the first chapter, haloalkenes that are haloarenes, and that the previous class means like that offline class we studied a few examples of is the whatever we are seeing on the screen like that SN reactions for that alkyl halides. So now let us start that next topic. Okay, here. So before going to start this that beta elimination reaction. So let us know about this that one small note like ambident nucleophile. So nucleophile such as what like cyanides or nitrate ions. So nitrate ions means like simply we can say as a what NO2. Okay? Like this that NO2. So NO2 just simply just we can write as that ONO. Otherwise, just a moment I will show you. See here we can write like this N double bond O minus. Okay. So the ambident nucleophile means the nucleophile which can attack the nucleophilic center from the both sides. See, so here the chances are there to be attacked like that nitrogen as well as that oxygen. So both sides can attack. So suppose if that oxygen can attack this the nucleophilic center, so we used to write like this that O N O. So that type of the nucleophiles is known as what ambident nucleophile. Now let us start that second part of alkyl halide. Sorry, just a moment. Yeah, SDR. So dehydrohallucination or beta elimination reaction. This is our the next topic. See, so when alkyl halides means a C beta. So here I have taken that one example like that CH3 CH2X, like CH3 CH2 and X. So when alkyl halides with the beta hydrogen atom, so we know that what is that beta hydrogen atom. So one, but even that once again I will explain that that halogen atom attached to those carbon that is known as that alpha carbon. Just I've written over here, and it's that adjacent carbon will be known as that beta carbon. So those hydrogen atoms are attached to that beta carbon is known as what beta hydrogen atom. So whenever this type of that compound, this type of the compound means now tell me, but this type of that alkyl halides now how many number of that alpha hydrogens are there? Mm, like three alpha hydrogens are there, isn't it? Na? How many? One, two, three. Three alpha hydrogens are there. So whenever this type of that alkyl halides is reacts with that alcoholic KOH solution, then they undergoes the dehydrohallucination. So dehydrohallucination means what? D stands for what? Removal. So what we need to remove over here that hydrogen as well as that halogen. So according to our that topic, hydrogen should be removed from, yes, from where? Beta carbon. So that means that one of any one of that hydrogen should be eliminated from over this compound. So whenever it is going to be eliminated, then the singly bonded molecules are converted to what? The double bonded molecule means that alkenes are converted to alkenes. Suppose if he had this that alkenes are there, then they converted what? Alkynes. So these eliminated of this that beta hydrogen atom is mixed with that OH minus of this that alcoholic KOH and removed as what? H2O, and that remaining that X minus is also eliminated and forms the main compound what? Alkene. So this type of the reactions are known as what? Beta elimination reactions. Yeah, my dear students. So if you wanna write, just you pause the video and just you can write on the notes of this one. So next, so here I given that example CH3CH2Br. That means that ethyl bromide when reacts with that alcoholic KOH. Chalo beta, just guess one. So what type of the compound should be obtained here? This one will be that alpha carbon and this is the beta carbon. So one of the hydrogen should be removed over here. Then CH3 is converted as what? CH2. Here the single bond is converted as what? Double bond. And CH2 means ethyl bromide is converted to what? Ethene. And removal of what? H2O water molecule and KBr. So let us try with that another example. And what is the name of the compound? One, two, three. So two, yeah, two, one, two, three. So 2 methyl, 2 bromo propane. Sorry, this one is the wrong. Actually, according to that alphabetical order, 2 bromo should be written first. So please better make it correct. 2 bromo, 2 methyl propane. So here that bromine is attached to the tertiary carbon. So simply we can say as the tertiary 1, 2, 3, 4. 4 carbon means that but. So tertiary butyl bromide. That means, yeah, according to this one, whenever it is going to be reacts with that alcoholic KOH solution, so this is the alpha carbon, Hana? This is the alpha carbon, and that beta carbon 1, 2, 3. So 3 beta carbons are there. So from this the tertiary butyl bromide, how many number of that alpha hydrogens are there? Guess beta. 3 plus 3 plus 3. So total number of alpha hydrogens are 9. So any one of that carbon can lose the alpha hydrogen with the OH minus of KOH can be removed as what? H2O. And that remaining that Br minus is combines with that potassium and moves out as that KBr. So that means here, according to that this compound, see better here that which hydrogen can be removed? CH3, CH3. Yeah, this one. So alpha hydrogen is that removed from this carbon. So now we got 2 methyl, 1, 2, 3. 2 methyl propane. Not sorry, it's not a propane. Propene. Double bond is there, na? So that means it belongs to that iso. 1, 2, 3, 4. 4 carbons are there. So butylene. So isobutylene. Here, yeah. Ah, okay. Okay, dear. So now let us learn about that one small note. So in case of that alkyl halides, if this the dehydrohalogen means that we know now, like that removal of one hydrogen as well as that halogen, and that hydrogen is should be that removed from that which carbon? Beta carbon. So the way of removal of these that elimination, like that beta hydrogen, that elimination is that two types, where we can study it like the CLASS-XII rule. So let us know about this. Is that CLASS-XII rule? What is that? When alkyl halide is heated by alcoholic KOH, it undergoes the dehydrohalogenation. As Baba, we know that. So then it gives alkenes in two different ways. So the preferenced alkene is means that preference means what? The major compound. This one. Okay. Just a moment. I will open spot. Yeah, now it's good to you. The major product with the carrier more number of that alkyl groups it attached to the carbon carbon double bonds. See here, so this is the one of the carbon carbon double bond, like that two type of that products here are obtained. So out of these the two products, so which one should be selected as that major product, and that major product should be means that selection is that followed by with the help of CLASS-XII rule. So CLASS-XII rule means here this is the carbon carbon double bond is there. So that means that unsaturation. So for this that unsaturation, see that, oh, for this that unsaturation here, uh, 1 and 2, two alkyl groups are there. But what about over here? This is the unsaturation. So for this that unsaturation, CH3, CH2 means that only one alkyl group is that attached for the unsaturation. Unsaturation means here attached to that carbon carbon double bond. So that can be generalized CLASS-XII rule. So that means here it consists two alkyl groups. So that's why can be named as what? Major product, right? 80%. See here, one of the note is there. Okay. Okay. Now let us know that one note. According to this note, the reactivity of alkyl halides towards that elimination reaction is as follows. What type of the alkyl halides? Primary, secondary, and the tertiary alkyl halides is having that more reactive towards elimination reactions. So I will try to give that one example for this one. So see that tertiary alkyl. Here I am taking the two type of the alkyl halides. Let's see CH3, CH2, and X. We know that this belongs to a primary alkyl halide. And CH3, whereas now this halogen atom is attached to what type of compound it is? It is the tertiary alkyl halide. So let us suppose that question may be given like is option A and option B and option C and option D, okay, something like that. Otherwise, that instead of option A and B, let us get that 1 and 2. Okay. So which of the following is that highly uh, reacts with the yes, this करो alcoholic KOH. This one is also alcoholic KOH solution. Gives what type of that product it is? Now write down. This is the halogen atom, so that means this is the alpha carbon and the beta carbon. So halogen atom can be, sorry, that a hydrogen atom can be, one of the hydrogen atom can be removed from over this carbon. So then how can we write? CH2 with the single bond is converted to double bond, CH2. And this hydrogen is mixed with the OH minus of the alcoholic OH and form H2O, and the remaining is that X is reacts with the potassium is the KX. What about this one? Huh? Right? Yes, karo. Any one of the compound. Let's see, because CH3, CH3. So I am removing that hydrogen from over here. This is the CH3 is converted as CH2. Then the single bond is converted at the double bond and the CH2. And this hydrogen should be interacts with that OH minus of these that alcoholic KOH, H2O, and KX. So that question may be given as like which of the following compound is that generalized to prepare that alkenes according to Setzep rule. So he may give raise a question like this. Okay, now then we need to opt this one because this compound is obtained by tertiary alkyl halide, which is having that more reactive like this. Tertiary alkyl halide is having that more reactive towards the elimination reaction. So next go to that node 2. So where is halides? Halides are going to be differ like the chlorine, bromine, iodine, but that alkyl group is the same. Then the reactivity order, iodine will be more reactive towards what? Elimination reaction. Okay. Now let us see that like differences between that what is the elimination and that substitution. See here what type of the compound is given, but see is one of that alkyl halide, whereas this one is that halogen is attached to this carbon is known as that alpha and its adjacent is that beta and having that hydrogen. If it is that removed, it follows is that elimination reaction, isn't it? So if one of the nucleophile is that attack to the alpha carbon, that would be what? Substitution. Means whenever the nucleophile is that is substituted, means attack on the alpha carbon, this that a halogen should be the replaced with the help of this that nucleophile. See, when alkyl halide with the beta hydrogen, I will show you that with the help of the spotlight. Just a moment. Yeah. When alkyl halide with that beta hydrogen, yes, here one of the beta hydrogen is there, is reacts with that nucleophile, or this is the nucleophile. Otherwise, that base compound, just like that alcoholic KOH means that OH minus. So undergoes both substitution, means attacking of that nucleophile is undergoes that substitution, and elimination of that beta hydrogen is that elimination reaction. Clear, beta? Okay, na? Sure. Chalo, next the third one, the reaction with that metals. First, it contains four types with the sodium. So sodium in the presence of dry ether, just we know that it followed by that Woods reaction. Second one is a reaction with metal, sorry, magnesium. Okay, and whereas the third one is the reaction with the lithium, and reaction with that lead, sodium, and alloy. Okay, now let us go to that first one with that sodium. Otherwise, that Woods reaction. See here we taken that one of that alkyl halide. Okay, this is the one alkyl halide. When reacts with that sodium metal in the presence of dry ether, it gives that alkyl halides are converted to what? With respect to alkanes. So, but whereas the tertiary alkyl halide do not undergo that Woods reaction. In the previous in the 11th class, we already learned the reason. Okay. So, according to this statement, now go for this example. Methyl iodide, when reacts with that sodium, it gives that ethane. Means that 2 moles. So we are already know in the class level. Next, second example, CS3, CH, CS3, that means that 1, 2, 2 iodopropane, that means that isopropyl iodide, sodium methyl, in the presence of dry ether. Okay, it gives two common, that means that whenever this that Woods reaction is that followed, the substrate should be the 2 moles. Don't forget about that one. Okay, now. So then only that alkane is that possible. CH, CH3, CH3, this compound, and this compound should be written in that one more time. CH3, CH3, like that 1, 2, 3, 4. So second carbon 1 methyl, third carbon 1 methyl. So 2 comma 3 dimethyl butane is obtained. Next, here one of the note is given about that Woods reaction. It's generally applied to prepare what? Symmetrical alkanes. See, this one is that symmetrical or asymmetrical? Obviously, it is that symmetrical alkanes, and also applied for what? Ascending of series, not descending, ascending. So the substrate ascending means what? Just increasing in number of the carbon atoms at the product side. Okay, so this is about with the reaction of the sodium. That means that it followed the Woods reaction. Next up. Okay, guys, if you want to listen, just go back and reverse the video and listen 1 second. Next, go to that second one with that magnesium. See, when alkyl halides is reacts with that magnesium metal in the presence of same dry ether, it forms. See better, when alkyl halide magnesium, it gives that RMgX. That means that alkyl magnesium halide is nothing but what? Grignard reagent. Same. Go for that live example. When methyl iodide is reacts with that magnesium, it gives that methyl magnesium iodide. So Grignard reagents are, we know that, is that organo metallic compounds which having a metal and that carbon bond. Okay, so where we know that this the Grignard reagent is that highly reactive, and they react with that proton donor RMGX. That means that Grignard reagents. See here, the topic is there. They can react with that proton donor. Proton donor is nothing but what? Acids to give hydrocarbons. See, when RMGX is reacts with that RZ. So here, let us suppose that Z is nothing but what? Nucleophile. Okay, that means that like proton donor. Then it gives that RH means one of the proton can be donate, and MgXZ. So that means that this R and this R can be combined. Otherwise, that suppose if that any alkyl group is not there, just a hydrogen atom can be attached to this that alkyl group. See, one of that live example is that C2H5. At the place of that alkyl group, I taken that C2H5 MgBr RZ is the proton donor. H2O, we know that in that H2O, H plus sign that OH minus, whereas that OH minus can be termed as what? Nucleophile. Okay. So C2H5 H plus, that proton donor means that H plus can be attacked over here. That remaining that Mg is that OH minus nucleophile can be merged with the metal, means magnesium. Okay, now say there one of the note is that, so since the H2O can react with the Grignard reagent, it is necessary that the use for the preparing this reagent must be is always should be what? Dry. So that's why this compound should be used. Yeah, yes guys. Next the third one with the lithium. After that, lead sodium alloy. Okay. When alkyl halides is reacts with the lithium in the presence of water, dry, the it gives salt compounds such as alkyl lithium. But don't forget, guys, the salts which it is obtained by this method, they can behave that strong bases. That means that here C2H5Li is a strong base. Just to go for this reaction, look at once properly, then you can understand. Chalo. Fourth one with lead sodium alloy. When alkyl halides is reacts with that lead sodium alloy in the presence of same the dry ether, they forms tetra alkyl lead. Suppose here that ethyl compound is taken, then what type of that product is obtained? Tetra ethyl lead. In short, we can write as, yes, guess it. We can write it as what? TEL, tetra ethyl lead. Okay, so these are the salt compounds. So next, fourth one, reduction. Okay. Okay, guys. Next, the fourth part, reduction. So when it has the two types. When alkyl halides, what is that? What are the two types? With that hydrogen or that nickel, and second one is that zinc copper couple reduction. Only two types. So just we can get this that so many examples are there in that class level. Uh, the, where better at the hydrocarbons, we are already learned about that reduction in the presence of that reducing agents. We saw that so many examples. Okay, just to check and the go for the previous. See, so when alkyl halides and reduction with the reducing agent, they reduce to what? Alkanes. So alkyl halides are converted to what? Alkanes. Let us go with that hydrogen over the nickel. So when alkyl halides is reacted with the nickel, use that instant hydrogen, then RH, HFCC. Okay. Example, this one check it once. Next one. Reacts with the zinc copper couple. When alkyl halide reacts with the zinc copper couple in the presence of 95% of alcohol like the CpH5OH, then which can reduce as alkanes. See the example. First, the zinc is react with the alcohol to form this type of the compound, complex compound to release that nascent hydrogen. Now, this nascent hydrogen is that reacts with what? Alkyl halide. Okay. ఆరిడ్స్ తో రియాక్ట్ అవుతుంది బేటా ఇది zinc copper ఇక్కడ ఆల్కహాల్ ఎంత పర్సెంటేజ్ what type of the sorry how much percentage should be taken 95% of alcohol can be taken then alkyl halides are converted to alkane. See the live example. So when C2H5Br is taken, C2H6 is obtained. Okay na? Next. So in the next class we are going to learn the chemical properties of halogens. Very interesting topic. Okay na? So don't skip that video also. So